All right, so today we are starting with the unit 2 of basic mechanics, ME161. So the unit 2 of basic mechanics, which is forces. I want you to stay tuned as I take you through. And at the end, I believe all the learning outcomes will be profitable to you. Stay tuned and let's go through. All right, so unit 2, we are looking at forces. So now we say that quantities or dimensions are either what? Scalar or vector. So what do we mean by a scalar quantity or a vector quantity? So we have quantities. Okay, so under quantity, you can either have a scalar quantity or you can either have a vector quantity. So we say the quantity is scalar when it has only magnitude, no direction. And we say a quantity is a vector quantity when it has magnitude and the quantity has what? Direction. All right. So now, this is when we look at a scalar quantity. It has only magnitude and no direction, but a vector quantity has both magnitude and a direction. So anytime you write a vector quantity or represent a vector quantity, it is always by an arrow like this. Sorry, a straight line like this with an arrow. Yeah, it's always a straight line like this. And most times they are represented like this, maybe 20 newtons, which is the magnitude, 0 to 0 degrees, which is the direction. So if you see anything notation like this, any concept or calculation where it has been given as this, in this form, then this is the magnitude, then this is what is the direction. All right. So now you have to first understand that quantities are either scalar or vector quantities. And all the basic quantities mentioned are scalar quantities with the exception of what? Of forces. So forces are what? Vector quantities. So previously in the lesson 1, you realize that we mentioned time. So time is a scalar quantity. We mentioned space. Space is what? A scalar what? Quantity. So these are all scalar quantities in the previous things class we mentioned. Mass, they are all what? Scalar quantities. Now the next point is, as such, forces are essentially treated as what? Vector quantities in rigid body mechanics. Now the external effect of force on a body depend on 1, the magnitude of the force, 2, the direction of the force, 3, the line of action of the particular force. So for instance, I have this particular marker here. If I apply a force in this particular direction towards the marker, you realize that depending on the magnitude of the force, it will either change the shape or the direction of this particular marker. So now, the external effect of forces on a body will depend on 1, how much force am I introducing on the body, which is the magnitude. What is the direction of force I'm coming from? Coming from a horizontal direction like this, the effect on the body will be different from me coming at an angle like this, an inclined angle like this. Or it will be different from me coming vertically like this on the particular object. So the direction of the force also matters, and the line of action of the force also matters. Now we say 2 or more forces acting on the body or a system of forces may be 1, collinear, parallel, coplanar, or what? Concurrent. So now, we can have collinear forces happening or acting on what? A body. So forces are collinear when 1, they act the same direction. So I can have this as force 1. I can have this as what? Force 2. They act on a straight line, either the same direction or different direction. So I can have also this as force 1, this as force 2. So since it is on a straight line, here they are acting on the same what? Direction. But here it is different what? Direction. So if we say the forces, when they act on the straight line, whether same or different direction, they are what? Collinear what? Forces. And also we say forces are parallel if they do not meet in space. So now we can have force 1, force 2. We can also have something like this, force 1, force 2. These forces will never meet. Yeah, force 1, force 2 here, acting upwards will never meet. Force 1, force 2 here, acting downwards will never meet. So we say these forces are what? Parallel to each other. These forces are parallel to each other. Now, so we also have coplanar forces. Now, the coplanar forces are forces that are acting in the same plane. They're acting in the same plane. Now, you can have a force like this, force 1 here, force 2 here, force 3 here, and you have force 4 here. But necessarily, they do not meet. They are not supposed to meet. So now, with coplanar forces, you can have force F1, force F2, force F3, force F4, acting in the same plane, but they do not meet. And we have the concurrent forces. Concurrent forces. These forces act at different angles, but they intersect each other in some space, or they move from a convergent point. Or in spaces, you realize that they move, and at a point, they intersect each other. So when forces at a point in space intersect each other, that point they intersect is what we call the concurrency point. The concurrency point. That is their point of of intersection, or their point of meeting. We call those forces co-current force. So anytime you have a system of forces, that system of forces may be collinear forces, maybe parallel forces, maybe coplanar forces, or maybe concurrent forces. When we say two systems of forces are considered equivalent if they produce the same effect on a rigid body. So if two forces are acting on the body, and those forces are producing similar effect on this particular rigid body, then we say the forces are equivalent, or they are equal forces. All right. Now, let's look at some characteristics of vector quantities or vectors. Now, when we say vectors may be fixed or bound, free or sliding. 2, we say vectors are considered equal if they have the same magnitude and direction. So, for instance, I have vector 1, which is V1. It has 20 Newton, 0 to 20 degrees. I have vector 2, which also has 20 Newton, 0 to 0 degrees. Now, I realize that vector 1 and vector 2 are equal. So, because they have the same magnitude and they have the same the same direction. And we say scalar multiplication of a vector changes only its magnitude, unless the scalar is negative, in which case a change in direction is also produced. So this is the example of it. Now, when a vector is towards this particular direction, let's say a vector is this way, and this vector is positive v, and I have a scalar quantity k, and I multiply a vector quantity. Let's say that vector quantity is x, and the theta is the direction, and I'm multiplying k times the magnitude of the vector quantity and the theta. We are saying that the change of the scalar quantity only happens to the magnitude. It changes only its magnitude, unless that scalar, if this scalar is negative, then the direction of this vector also changes, but the value will affect the magnitude. But when you are done and you are drawing your final vector, it will change. The direction will change and become negative VE. So if the scalar you are multiplying is negative, then it affects the value of the magnitude, and it will affect the direction, just changing the direction. So in vectors, very simple. If I have this as my positive VE, and I want to change this vector direction, it is just by changing the arrow and becomes my negative VE. So that is what happens if the scalar quantity you are using for the scalar multiplication is negative. And take note, the vectors also obey the parallelogram law of addition. They obey the parallelogram law of addition. So we continue with the characteristics of the vectors. They also obey triangular law. The triangular law. So they obey parallelogram law and they obey the triangular law. So now, with the triangular law, let's make it very simple here so that we all understand. So that we all understand it very well. So this is what it means. I have a vector direction here. Let me call this vector vector A. And I have another vector direction here. Let me call this vector B. I want to find my resultant vector. So the triangular law says that if I have two sides meeting up together, then the third line I draw to complete the triangle becomes the resultant vector. So when I draw this to meet this one here, which is also moving towards this direction, the resultant vector become A plus what? B. And when this law is at work, we say it is called what? The triangle law. The triangle law of vectors. The triangle law of vectors. Now, they also obey the sine and the cosine laws. They also obey the sine and the cosine laws. So I want to make the sine and cosine laws very, very easy. So now, I have three sides of a triangle. I have three sides of a triangle. Let me call this side A. Let me call this side B. Let me call this side C. So let me call this angle an alpha angle. Let me call this angle a beta angle. Let me call this angle a gamma angle. All right. So I want you to watch it very well. Now, first of all, let's look at the sine laws over here. And here we look at the cosine laws. So what does the sine law say? So the sine law says that when I pick a side of the triangle, I divide it by the opposite angle inside the integral form of the triangle. When I pick a side, I divide it by the sine of the angle inside. When I pick a side, I divide by the sine of the angle inside. So cosine law says that A, when I pick A, divided by the sine of what? Of the gamma, because that is the opposite angle. Sine of gamma is equal to, when I pick B, I divide it by the sine of the opposite angle, which is sine what? Alpha. That is equal to, when I pick C, I divide it by the sine of the angle, which is also opposite the sine of sine what? Beta. Okay, so this is the sine law. So I can pick any of them, equate, and find which one I'm supposed to find when I'm given a question. But in the cosine laws, this is how it works. I want to find the side of one of the triangles. So I'm starting from A. If I want to find A squared, this is what happened. We say A squared is always equal to the other two sides, which is B squared plus C squared minus 2BC times the cos of the angle that is between them, which is what? Alpha. This is the cosine law. So the cosine law says that I want to find the side of the triangle. So the square of this side of the triangle is equal to the square of the other two sides minus 2 times the product of the other two sides times the cos of the angle that is between the other two sides. Yeah, it makes it very simple. So for instance, I want to also find B squared. So B squared is equal to A squared plus C squared minus 2AC cos the angle that is between what? A and C, which is angle what? Alpha. Are we getting it? Or better still, the angle that is directly opposite to the side we are finding. Alpha is directly opposite to the side we are finding. That one will make it very simple for you. And also too, if I want to find C square, it is equal to what? A square plus B square, A square plus B square minus 2AB cos the angle that is between A and B, or the angle that is opposite to what? The C we are finding, which is what? Beta. So now these laws are what we refer to as what? The sine laws and the cosine laws. So we say vector quantities. Anytime you have a vector quantity, they obey both either the sine law or what? The cosine law. All right. So that is what you find here. A square is equal to B square plus C square minus 2BC cos the alpha, which is alpha. This one, which is between them. All right. All right. So we are continuing. We say vector forces obey the polygon rule of addition. The polygon rule of addition. So let me just do it simple here so that you know. So first of all, let's say we have A, and let's say we have this structure as what? B. So we have vector A, we have vector B. So we say in triangular law, the third side that close them following this direction will be what? Our A plus B. So let's say we also have another vector connecting from vector B, and we call that vector C. Then the polygon rule says that if you want to close this particular three vectors, then the sum of the three vectors will give us the resultant vector, which is what? A plus B plus C. So this is what? The polygon what? Rule. But one thing you should take note, always check the direction of the vectors. For instance, if let's say the vector B was like this, it will not work. So you have to change the direction of vector B to like this before it works for the system. You get it? So if vector B was like this, then you have to change the direction of vector B to this. Now, if you have a vector like this, and this vector is positive V, and I change this vector to the direction of the vector, all I have to do is to change the sign. It becomes a negative vector. So for instance, let's say vector B was, okay, let's say here, vector B was like this, which is negative 20 Newton. And it has to obey the polygon rule, so the direction of this vector has to change to this direction. Then the magnitude becomes what? 20 what? Newtons. Please, are you getting it? So this is what happens when you change the direction of a vector. It also affects what? The magnitude of direction. And this is the polygon rule of addition. Now I also said vectors, that is successful application of the parallelogram triangular law what is possible. So any successful application of what? A parallelogram law, we have triangular law, which is what? Very possible. Because parallelogram is just a shape with what? 4 sides. So for instance, if you look at this, it is 4 sides. Yeah. Now vector addition is commutative and associative. So we say it's commutative when, for instance, A plus B is equal to what? B plus C. And we say it is associative when we have A plus B plus C is equal to A plus into bracket B plus C. So this is commutative property. This is what? Associative what? Property. All right. So that's why you see here vector P plus vector Q should be equal to vector Q plus vector P. And vector P plus vector Q all in bracket plus vector S should be equal to vector P plus all in bracket Q, vector Q plus vector S. All right.